Hey folks, this is Randy Jackson, and this calculus lesson is part one of volume by cylindrical shells. All right. So remember when we did disk and washers, you guys. Sometimes you have difficulty. So for example, say we're going to find the volume of this curve right here, y equals 2x squared minus x cubed, and we're going to revolve this around the y-axis. And so if you slice perpendicular to the y-axis, you get washers. So there would be this washer that would be going around the y-axis right there. But the inner and outer radius is going to be kind of hard to solve because you have to solve this in terms of x equals y squared, because when you're revolving it around the y-axis, you got to have an x equals y equation. So to solve this for x makes it really difficult, you guys. So what happens when this case happens is cylindrical shells, the new method I'm going to show you on this lesson, it becomes really useful. So you get a picture that kind of looks like this over here. Okay, and this method works is most useful when you're revolving variables around your variables that you're revolving around. Say I had y equals x equations and I'm revolving it around the y-axis. That would be a cylindrical shell one. So if your equations are opposites of the axes that you're revolving it around, the shell or the cylindrical shells would be a better option like that. Sorry, I'm getting a little tongue twisted here. If they match, then you do what we did in the last lesson, and you do the disk and washer method. So can you see, and imagine I have this y-axis going down right here, okay? And then so I'm doing this shell that goes all the way around. I'm going to find the volume of the shell. So we're going to have the outer shell minus the inner shell. Okay, the outer shell, think of a cylinder, you guys. A cylinder is going to be pi r squared for the circular part right here, pi r squared, and then times the height. That would be the volume of the outer shell. And then the inner shell is pi r squared times its height. So the one r has radius 2, and the second r has radius 1. Okay, so the shell part is going to be the subtraction of those two, the outer minus the inner. Okay, you guys with me there? Say yes. All right, and then so what I'm going to do is GCF out the pi r squareds out of both of these right here. So I'm sorry, the pi h's, my bad. So I've GCF the pi h's out, and I'm left with r sub 2 squared minus r sub 1 squared. You guys with me there? And then remember from Algebra 1, this is a difference of squares. This becomes r sub 2 plus r sub 1 times r sub 2 minus r sub 1, which is that right there. Okay, and then what I'm going to do is I'm going to insert a 2. Okay, so all I did was, here's 1. This is just 1 right here. This is my 2 over 2 right there. But the reason why I did that is I want you to recognize that this is the average of the radii right there. R2 plus R1 over 2 is the average of the radius. And then this is just the thickness of it right there. Okay, so R2 minus R1 is just the thickness right there. Okay, and then so let's do a little bit more on that. Okay, so I just rearranged them, and so this is actually my x coordinates. If this is my y-axis right here, then the radius 2, I'll call it x2, and the radius 1 is x1, and so here's x2 and x1 again right here. So what happens is it starts developing, I'm going to call this my x right here. This is my 2 pi right here, and my x is always, in this case, it's going to be right one minus left one, right equation minus left equation right there. Okay, and this is the height is my f of x, and then this is just my delta x right there, my change in x right there. Okay, and so what happens is my volume, this is still my volume is 2 pi times the sum of all the x's times the f of x's times the delta x's. So that's what I have right here. Okay, so then, so remember this is my integral part right there. So I'm going to just insert my integral part right there. And then so we're going to do, if we have y equals f of x equations right here, if this is an x and we're going about the y-axis, I'm going to do the shell method, okay? So I'm going to have, these are x limits right here. This is x equals and x equals right here. So this is x, and then this would be y equals something in terms of x, y equals x equations. And then if it's x equals y equations and we're going about the x-axis, do you see how these are opposites of each other? Then I'm going to do the shell method. And this is my formula for the shell method right here. All right, so let's try a couple of these, okay? And then okay, if it's y equals f of x equations, you guys, then we do top minus bottom. And if it's x equals x equals y equations, then it's righty minus lefty right there, okay? All right, so let's find the volume of the solid of the region bounded by, here it is, y equals an x stuff equation, y equals 0, and it's going to be by going around the y-axis. So since this y-axis and this is y equals x equations, these are opposites of each other, so I'm going to use the shell method. Okay, if they were the same, I'd use the disc and washer method. All right, this is just a parabola, and I just like to graphing this parabola so I can see what my limits are going from right here. Okay, because it's y equals x equations, and I got to have x limits. This is x equals 0. This is x equals 2 right there, and it's going to go around, so it's going to be 2 pi times x times f of x, so 2 pi times x times f of x, and then we're going to do top equation, which is this blue parabola, minus the bottom equation, top minus bottom. Okay, so here it is right there. So the top is y equals 2x minus x squared. It's this equation right here, and the bottom is this right here, y equals 0, the x-axis, y equals 0. So there's my top minus bottom, going from x equals 0 to 2. Don't forget your x right there. Okay, now it's just the integral stuff from basic calculus that we learned how to do before. Okay, so when you integrate, you should get 8 pi over 3. All right, so again, remember, if they're opposites of each other, then you're going to go ahead and use the shell and the cylindrical shell method. If they're the same, then you use disc washer method, which is from the last lesson. Okay, this is just a reminder how to do your graphing calculators right here. So I could have plugged this in right here and plugged that into the graphing calculator and got my decimal version of 8 pi over 3 right there. Okay, so that's just a reminder how we did that in your calculators, whether you do a Casio or a TI, and I did this guy right here. Okay, so I did that in one of my other lessons. I forgot where I did that. I just copied and pasted it. All right, so find the volume of the solid of the region bounded by, this time it's x equals y stuff, and we're going about the x-axis. So it's y stuff and x-axis. So again, this is going to be a cylindrical shell method. So volume equals 2 pi. Okay, I graphed it over here so I can see what are my y limits right here. I needed to know my y limits. Okay, so what I did is I put this, since my graphing calculator graphs y equals x stuff, I put in my graphing calculator y equals 2x cubed minus x to the fourth, and then I turned it 90-degree clockwise, and then you got to flip your calculator upside down. Okay, don't forget to flip it upside down. I think I forgot that in my last lesson about flipping it upside down, but you got to flip it upside down, okay, to make it look like this. This is what the graph should look like. So this is how this graph graphs, is right here. And all I'm interested in is this y limit, y equals 0, and this y limit, y equals 2. And how do I get those? I just solve for y with this equation. I set that equals 0 right there. Okay, because I want to know when is this x value going to equal 0. It's going to equal 0 right there and right there. Okay, so here we go. So I'm going to use my volume method for my cylindrical shell. So y times righty minus lefty. Okay, so here's my right equation minus my left equation right here, x equals 0. Okay, I'm sorry, y equals, so right minus left. Okay, and then, whoops, I forgot to put my limits in there, but my limits are going from 0 to 2. Okay, you with me? Okay. Alrighty, so, and I get that right there is my answer. Alright, sorry, I'm a little tongue-tied here, and I'm running out of time. My wife is coming home, and I got to have things put on the stove before she gets home. I'm cooking dinner tonight. Anyways, okay, so find the volume, one more problem. Find the volume of the solid of the region bounded by y equals x cubed plus 1. That's a cubic equation, and then this linear equation, y equals 1/2 or 1 minus 1/2 x, x equals 1 about the y-axis. Okay, so these are y equals x equations, y-axis, so this one's a cylindrical shell one. Okay, so I did this one in blue, y equals x cubed plus 1, that's this blue guy right here. I did x equal 1 in red, and I left this one in black right here. So this linear equation is I went up here at this plus 1 and then used this slope down 1 to the right 2 and graphed that. So it's this kind of little shape right there. Okay, so that's my shape right there. And since these are when y equals x equations, I need x limits. So x goes from 0 to 1 right there. Okay. So, and then it's going to be top minus bottom. So it's the top equation minus the bottom equation. So the top equation is this blue guy. The bottom equation is this this linear line right here. So top minus bottom. So it's the cubic minus the linear. Don't forget your x right there. And then you go ahead and integrate that. You should get 11 pi over 15. Alrighty, don't forget, you guys, when you're doing shells, the shell method, you guys, this has to be, so this is y equals f of x, and we're doing it around the y-axis. These are opposites of each other. These are x limits right here. If they're y limits, yeah, they're y limits, and you have x equals y equations, and it's going about the x-axis. These are shell methods right there. All right, so remember, this is part one. I'll do part two probably in a day or so. And that would be my assignment if I had you as my students. Take care, you guys.